Hey guys, today we're going to talk about how to calculate dew point and relative humidity. And to calculate humidity, or to measure humidity, we use a device called a sling psychrometer or a regular psychrometer. A psychrometer has two different thermometers on it. One is called a dry bulb, the other is called a wet bulb. So, what does that mean? It kind of looks like this. A dry bulb thermometer is a regular thermometer that's attached to the psychrometer, and the wet bulb thermometer is also a regular thermometer, but it's attached to a cloth that's wet. Okay, so when we swing it around, it's kind of used like this. What happens is the dry bulb thermometer still measures the regular air temperature like a regular thermometer does, but the wet bulb thermometer temperature starts to decrease. That's because the wet cloth here, the water starts to evaporate into the atmosphere. When water evaporates, it actually cools down the surface that it evaporates from. That's because it takes away energy from the surface. This is very similar to when you get out of the swimming pool and you feel cold when the water starts to evaporate, um, or when you start to sweat and the sweat evaporates, it cools you down. So what happens is the wet bulb thermometer helps us figure out the humidity of the atmosphere, because if the atmosphere already has a lot of water vapor, it won't let any more or much water vapor to enter the atmosphere. That just means that the wet bulb thermometer won't evaporate as much, or the water from the wet bulb thermometer won't evaporate as much into the atmosphere when the atmosphere already has a lot of water vapor. But if the atmosphere is very dry, a lot of this water from this cloth will evaporate out into the atmosphere because there's more room for that. And if we take the difference between the dry and wet bulb, that can help us figure out how humid the air is or how much water vapor there is in the air. So if we take a closer look at the dry bulb and the wet bulb's temperature should decrease because the water is evaporating. But when the water does not evaporate from the wet bulb, or doesn't evaporate much, that means that the atmosphere already has a lot of water vapor and it can't have any more, take away any more from the wet bulb. So when the wet bulb and dry bulb temperatures are close together, meaning the wet bulb temperature didn't change much, it just means that the water didn't evaporate much. It also means that the air is close to max capacity of water vapor. That's why there's not much evaporation happening. That also means that the relative humidity is close to 100%, meaning the air already is very close to having 100% of water vapor, so it can't take any more from the wet bulb. It also means that there's a greater chance of clouds and precipitation because the air is so humid. So if you would like, go ahead and write this down in your notes. This is something we will come back to. Make sure you open your reference table page 12, and we use reference table page 12 to calculate dew point and relative humidity. If you look at the dew point chart in the top, notice that dew point depends on two things: the difference between the wet and dry bulb temperatures. These are all my numbers for the difference between the wet and dry bulb temperatures. It also depends on the dry bulb temperature, and these are all my numbers for the dry bulb temperature. All these numbers in the middle are my dew point. That's why this is the dew point chart. We can use the difference between the wet and dry bulb and the dry bulb temperature to find out what the dew point is based on the numbers in the middle. The relative humidity chart in the bottom is also similar. It also depends on the difference between wet and dry bulb temperature and the dry bulb temperature. All the numbers in the middle are the relative humidity in the relative humidity chart. So you have to make sure you go to the right chart to figure out whether you're calculating relative humidity or dew point. Notice that when the difference between wet and dry bulb temperature is zero, meaning that the wet bulb temperature and dry bulb temperature are pretty much the same, exactly the same, none of the water evaporated from the wet bulb, the relative humidity is actually 100%. The reason is when the relative humidity is on 100%, the air already has max capacity of water vapor. So no water will evaporate from the wet bulb, and therefore the difference between the wet bulb and dry bulb temperatures will be the same or zero. So let's start with question number one. I'm going to show you how to do a few questions from this chart. After watching this video, try the whole table out. So number one is giving us the dry bulb temperature. It's giving us the wet bulb temperature. We need to find the difference between the dry and wet bulb temperature. Difference just means minus, subtraction. The difference between dry bulb and wet bulb is dry bulb minus wet bulb. Bigger number minus smaller number. The wet bulb is most of the time a smaller number because when the water evaporates, the temperature starts to cool down. And the reason we do the bigger number minus smaller number is because we want a positive number. All your numbers for the difference is positive. So the dry bulb is 12, the wet bulb is 7. The difference between them will be 12 minus 7, which gives us 5. So go ahead and write down 5 for the difference between dry and wet bulb. Next, we need to find the dew point temperature. So we need to go to our dew point chart. And if we go to our dew point chart, we're given the dry bulb, which is 12 degrees Celsius. Here's my dry bulb temperature, 12 degrees Celsius. We're also we also now found out the difference between dry and wet bulb temperature, which is 5 degrees Celsius. Be careful not to use just the wet bulb temperature. You always need the difference, the subtraction. So the difference between dry and wet bulb is 5. So if we combine them in our chart and we look in the middle, we find that our dew point is 1 degree Celsius. Make sure you're looking at the dew point chart and not the relative humidity chart when you're looking for dew point. So go ahead and write this down in your answer for dew point temperature, 1 degree Celsius. To find the relative humidity, we have to go to the relative humidity chart. And if we go to the relative humidity chart, we're still looking at the same variables. My difference between the dry and wet bulb is still 5. My dry bulb is still 12. For my relative humidity chart, the numbers in the middle are just different. So if we combine that, the number is 48. So the relative humidity is 48%. Go ahead and write this down. So let's try question number 5 on the table. We're given the dry bulb temperature, we're given the difference between dry and wet bulb temperature. We can find out the wet bulb temperature based on these two variables. So remember, the difference between dry and wet bulb is dry bulb minus wet bulb. If we do some simple algebra, we can figure out the wet bulb temperature. The dry bulb minus the wet bulb is 1. That's my difference. And my dry bulb is 21%. Sorry, 21 degrees Celsius. So 21 minus x is 1. In this case, x represents the wet bulb. That means 21 minus 1 is x, and x is 20 degrees Celsius. And that leaves us with the wet bulb being 20 degrees Celsius. Go and write this down. You can see that 21 minus 20 is 1. That matches up. Next, we need to find the dew point temperature, so we should go to the dew point chart. Here's a dew point chart. We have the dew point, we have the difference between the dry and wet bulb now and the dry bulb. Never use just the wet bulb for your answers. So the dry bulb temperature is 21 degrees Celsius. Notice that there is no 21 here. But we know that 21 is somewhere between 20 and 22, so we'll look somewhere over here. My difference between dry and wet bulb is 1 right here. And if we combine that, my answer is somewhere between 19 and 21. The number that's between 19 and 21 is 20. So that's why my dew point temperature is 20 degrees Celsius. So whenever you don't have the number written out, try to find the number in between and estimate a number in between the numbers that are given to you. In this case, the dew point is 21. So let's try question number 12. Question number 12, we're given the difference between dry and wet bulb, and we're given the dew point temperature. We need to find the dry bulb temperature. So we can go to our dew point chart since we're given our dew point temperature, and we can do a reverse of what we've been doing. So the dew point, the difference between dry and wet bulb is 1. That's right here. And since we're given the dew point temperature, which is 14, remember the dew point temperatures are the ones in the middle, all these numbers, right? And 14, my dew point temperature for this particular number should be somewhere in the 1 column because my difference is 1. And I'm looking through this column for 1, and I find 14 right here. Now that I found 14, which is my dew point, I can just go towards the left to find the dry bulb. And in this case, my dry bulb is 16 degrees Celsius. So go ahead and write down 16 degrees Celsius for dry bulb. Next, we need to find the wet bulb. And once again, we're going to do some simple algebra. Remember, difference between dry bulb and wet bulb is dry bulb minus wet bulb. The dry bulb minus wet bulb in this case is 1. And my dry bulb is 16. So 16 minus x equals 1. Wet bulb represents x. So 16 minus 1 is x, and x is 15 degrees Celsius. That means our wet bulb is 15 degrees Celsius, and you can write that down right here. If you to check your answer, notice that 16 minus 15 is 1. That works. Lastly, we need to find the relative humidity, so we should go to the relative humidity chart. And in the relative humidity chart, we're once again using the difference between the dry and wet bulb temperature and the wet bulb temperature. So my difference is 1 and my wet bulb temperature is 16. So if I combine that, I see that my relative humidity is 90%. That's very close to 100%. That means my air temperature has a lot of water vapor in it. And that makes sense. Note that the dry bulb and wet bulb temperature are very close. If my air already has a lot of water vapor, not much water will evaporate, and my wet bulb temperature should not change much from the regular temperature. Also notice that my dry bulb temperature is very close to the dew point temperature. My dew point temperature is the temperature at which the air will become maximum amount of water vapor, 100% capacity. So if my dry bulb temperature is very close to my dew point temperature, that means my air temperature just has to cool down a little bit to become max capacity water. My air is very humid. My relative humidity is very close to 100%. That's also a sign. And this all means that there's a high chance of clouds and precipitation because the air is so humid. So let's try number 13. In number 13, we're given the dry bulb temperature and we're given the relative humidity. This time, I need to find the difference between dry and wet bulb. The reason I'm starting with this because I'm given the dry bulb, I'm given the relative humidity. It's going to be very easy for me to find the difference right here. So start with the dry bulb. I'm going to start actually with the relative humidity chart since I'm given the relative humidity, and I'm going to find my dry bulb. My dry bulb is 22 right here. My relative humidity is 15 degrees Celsius. Remember, all the numbers in the middle are the relative humidities, right? I'm going to look for 15 in this row for 22 because my dry bulb temperature is 22. So if I look for 15, I find that 15 is right here. So my relative humidity is 15%. And I just have to go up to find the difference between wet and dry bulb. And if I go up, I see that my difference is 12. So my answer for the difference between dry and wet bulb is 12 degrees Celsius. Go ahead and write this down. Next, I can find the wet bulb using my simple algebra. So remember, the difference between dry and wet bulb is dry bulb minus wet bulb. In this case, my dry bulb minus wet bulb is 12. My dry bulb is 22, so 22 minus x is 12. Remember, wet bulb is x. 22 minus 12 is x. X is 10 degrees Celsius, so my wet bulb is 10 degrees Celsius. Go ahead and write this down. Next, we need to find the dew point temperature, so I'm going to go to my dew point chart. And notice that I have my dry bulb temperature, which is 22. I have my difference between wet and dry bulb, which is 12. I just combine them, and I find that my dew point temperature is negative 5 degrees Celsius. Lastly, go ahead and try the rest of the questions in that chart, and in the bottom of your worksheet, try this question out. The table below shows the air temperature and dew point at each of the 4 locations A, B, C, D. You have the air temperatures for these locations and the dew point temperature. Number 14, write this down in the bottom of your chart. Which location, A, B, C, D, has the highest chance of precipitation? How do you know? Make sure you talk about the air temperature and the dew point in your answer. Check with your teacher after you're done, and thank you.